Hi GOH, this is Unit 6, Lesson 1, and we're going to talk about properties of parallelograms. So we already talked a little bit about this in Unit 5, but we're going to do it more formally here. So a parallelogram is a quadrilateral. Quadrilateral just means that it has four sides. It's a quadrilateral with both opposite sides parallel. So it's a quadrilateral with both opposite sides parallel. So that means the top is parallel to the bottom and the left side is parallel to the right side, and that's how I can show that those opposite sides are parallel to each other. All right, some other properties of parallelograms is that the opposite sides are congruent to each other. That means they have the same length. And the opposite angles are congruent to each other. They have the same measure. So we're actually going to try and prove some of those properties. So in exercise 1, I have parallelogram ABCD. AB is parallel to DC, so that means the top is parallel to the bottom. And AD is parallel to BC. And diagonal BD is drawn with certain angles numbered. Let's list all the pairs of supplementary angles based on the fact that AB is parallel to CD and AD is parallel to BC. All right, so supplementary angles are angles that add up to 180. Okay, so basically angle A is supplementary with angle ADC. Angle A and angle ADC are supplementary. Because if you remember, if I have two parallel lines and a transversal, the angles right here and here are same side interior angles. Those are supplementary. So that's exactly what I have in this picture. Angle A and angle ADC are supplementary. Angle B and angle BCD are also supplementary. Okay, so angles that are next to each other are same side interior angles. Those are supplementary. Also, angle A and angle ABC are supplementary. Okay, because if I have two parallel lines that are going like this and a transversal, these are still same side interior angles. And angle C and angle ADC are also supplementary. So there's a whole bunch of supplementary angles. Any angle that is next to each other is supplementary. All right, so let's prove some of the properties that we listed up above. We want to prove that opposite sides are congruent, and we want to prove that opposite angles are congruent. So angle ABCD is a parallelogram. That was given. That was told to us. So that's easy, given. This got cut off a little bit. This should say that AB is parallel to DC and that BC is parallel to AD. And the reason is it's definition parallelogram. That's exactly what a parallelogram is as opposite sides are parallel to each other. So definition parallelogram. Step 3 says that angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4. All right, so angle 1 is congruent to angle 2 and angle 3 and angle 4 are congruent. That's because those are alternate interior angles. Remember, the lines are parallel, so alternate interior angles are congruent to each other. Step 4 says that BD is congruent to BD. Well, that's my reflexive property. Step 5 says that triangle ABD is congruent to triangle CDB. Well, they're congruent by angle, side angle. And if the triangles are congruent, then those corresponding sides and angles are going to be congruent. So AB is congruent to DC, and angle A is congruent to angle C by CPCTC. So basically what I just did is I proved that opposite sides are congruent, and I proved that opposite angles are congruent. And I only proved one of those, but that's what I proved. So we listed that property right here. Opposite sides are congruent and opposite angles are congruent, and now we just proved it. Okay, if I drew in diagonal AC using a straight edge, are the two diagonals congruent to each other? So oops, let me just draw that in. Let me grab a new color here. So if I want to draw in AC, okay, so using a straight edge, and then I took out a ruler and measured them, AC is going to be much, much, much shorter than BD. I can tell just by looking at them, but you can confirm it with a ruler if you want to. AC is much shorter than BD. So those diagonals are not congruent to each other. And that's what we really wanted to discover here. So no, they are not congruent. BD is longer. All right, let's turn over. Parallelogram properties can be explored and then proven using Euclidean proof. They can also be explored using the tools of coordinate geometry. So on the diagram, I have quadrilateral RSTU, and I want to prove that it's a parallelogram using coordinate geometry. So that means I'm using the points. Now think about, we learned some formulas back in the last chapter. I learned slope, distance, and midpoint. Think about what formula would help me to prove that it's a parallelogram. Remember, a parallelogram has opposite sides parallel. So think about parallel. The formula that's going to help me to prove that opposite sides parallel is my slope formula. But I'm going to have to find the slope of RS. I'm going to have to find the slope of TU, that's the top and the bottom. And then I'm also going to have to find the slope of the left side and the right side. So I'm going to have to find the slope of ST, and I'm going to have to find the slope of RU. And we did this in the last chapter, but we're going to do it more in this chapter here. So remember slope, my slope formula is the change in y over the change in x. So I subtract the y's, that goes on top, and I subtract the x's, that goes on the bottom. So just take your time, make sure you're picking the right point. So I want to do RS. So 6 minus 3, I subtract the y's. 9 minus 0, I subtract the x's, which gives me 3/9 or 1/3. Then I'm going to find the slope of TU. So make sure you're looking at the points for T and U. -2 minus 1, -3 minus 6, -3 over -9, which also is 1/3. So remember, if I'm trying to prove this is a parallelogram, I need opposite sides to have the same slope, because if they have the same slopes, they are parallel. I'm going to find the slope of ST. 1 minus 6, 6 minus 9 is -5 over -3, which is 5/3. And last one, RU. Just make sure you're looking at points R and U. You could put your fingers on the points if you want to confirm. -2 minus 3, -3 minus 0 is -5 over -3, which again is 5/3. All right, so I need like a little statement here, and I can say that RSTU is a parallelogram because both opposite sides are parallel. They have the same slope. And that is called a coordinate geometry proof. All right, then they want us to show that RU is congruent to ST using coordinate geometry. So if I want to show the length of anything, that's my distance formula. So I'm going to find the length of RU. Okay, so I'm going to use my, my distance formula, RU. So make sure you're doing R and U. So I'm going to subtract those x's, -3 minus 0 squared. I'm going to subtract those y's, -2 minus 3 squared. Remember, any negatives are going to be squared, so that's okay if they're negatives. So that's going to give me 9 plus 25. And we don't need to worry about simplifying as long as we get the same thing, it's fine. So that's what's nice about these coordinate geometry proofs. You do not need to simplify when you do your distance formula. So then I'm going to do ST. So I got 9 minus 6 squared plus 6 minus 1 squared, 3 squared plus 5 squared. So again, that's 9 plus 25 equals radical 34. All right, so I would say RU is congruent to ST since they have the same length. That is another way that I can actually, same length. If I wanted to prove it's a parallelogram, since opposite sides are congruent, you can show that both opposite sides are congruent by using the distance formula 4 times. I think the slope formula is easier to use than the distance formula, so I would rather do that. All right, and then using the midpoint formula, I want to find the midpoint of diagonal RT and SU. What observation can you make about these? What does it tell you about the diagonals? Draw them in to visualize. So I'm going to draw in RT. And I'm going to, oops, let me scoot down a little bit. And then I'm going to draw in SU. Okay. And I want to find the midpoint of each of those. So the midpoint of RT, just make sure you're using R and T. If you want to write down the points again, you certainly can, just to make sure that you're taking the right ones. Midpoint, I add the x's, divide by 2, add the y's, divide by 2. So that's giving me 3, 2. And midpoint of SU, so S is 9, 6. U is -3, -2. Again, you're going to add the x's, divide by 2, add the y's, divide by 2. So that will also give me 3, 2. So what observation can I make? They have the same midpoint. If they have the same midpoint, then that means that they bisect each other. Okay? Diagonals bisect each other. They're not the same length of diagonals, but the diagonals bisect each other. And that's something we also learned in Unit 5. Okay, so this is going to go more into detail with these figures. Given a parallelogram MNNP shown with diagonals MP and NQ intersecting at point R, prove that NP and NQ must bisect each other. All right, so this is a formal proof. MNPQ is a parallelogram. That was the given. Okay. MN is congruent to QP. So basically, I want to prove that MP and NQ bisect each other. If they bisect each other, then I really need like this segment congruent to this segment and this segment congruent to this segment here. So what I'm going to do is I'm going to prove that this triangle is congruent to this triangle, and if they are, then their corresponding parts are congruent to each other. All right, so that's my goal right there. I know it's a parallelogram, so I know that MN and QP are congruent because opposite sides of a parallelogram are congruent. That's something we already proved, so now that's something that I can use. I know that MN is parallel to QP. So the top is parallel to the bottom. I know these are congruent and I know they're parallel. The left side and the right side are also congruent and parallel, but they don't have anything to do with the triangles that I'm trying to prove, so I'm not going to add that in. It's not wrong to add that in, but I don't need it. Now I know those opposite sides are parallel because that's the definition of a parallelogram. And if those opposite sides are parallel, that makes angle 1 congruent to angle 2, and it makes angle 3 congruent to angle 4. because those are alternate interior angles. Alternate interior angles are congruent. So basically, I have enough right now to say that those triangles are congruent to each other. Triangle MNR is congruent to triangle PQR. And the reason, look at my picture, how I've marked everything. The reason is angle, side angle. Now, if the triangles are congruent, then that makes MR congruent to RP. In fact, I think I'm going to switch colors right now. So MR is congruent to RP. This one's congruent to this one. And I also know that NR is congruent to RQ. This one is congruent to this one. Okay, and the reason is CPCTC. And if those segments are congruent, then that means that MP and QN bisect each other. So I did it. I proved that the diagonals bisect each other. And that's just definition segment bisector. Okay, so we did it with our midpoint formula to show that they have the same midpoint, and now I just did it with an actual proof. So we did it two different ways. Okay, so we will be